Good morning, students. Today we are going to discuss graphical method of representing pair of linear equations, graphical representation. In the previous section, you have seen how we can graphically represent a pair of linear equation. There are three possibilities. One is intersecting lines, second one is coincident lines, and third one is parallel lines. And you also know that when the two lines intersect, you will get only one solution. When the two lines coincident, you will get many solutions. When two lines are parallel, will not get any solution for the given pair of equations. Today we are going to discuss once again the same concept, that is intersecting lines, parallel lines and coincident lines. Now, when the two lines are intersecting, then you will get only one solution. So we call it as consistent pair of linear equations. When the two lines intersect at one point, then we call it as consistent pair of linear equations. When two lines coincident, then you will get many solutions. We call it as dependent pair of linear equations. Dependent pair of linear equations. When the two lines are parallel, then no solutions. We call it as inconsistent pair of equations. Whenever the two lines intersect, we call it as consistent pair of equations. When the two lines coincident, we call it as dependent pair of equations. And when the two lines are parallel, we call it as inconsistent pair of equations. In the previous section, you also learned the general form of pair of linear equation. What is the general form of pair of linear equations? That is a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0, where a1, b1, c1, a2, b2, c2 are the real numbers, and a1 square plus b1 square is not equal to 0. Here a2 square plus b2 square is not equal to 0. This condition is very important. A1, B1, C1 are real numbers, and in this equation A2, B2, C2 are also real numbers, but A1 square plus B1 square not equal to 0, A2 square plus B2 square also not equal to 0. Now, what is this A1, B1, C1, A2, B2, C2? A1 is coefficient of x, and here A2 is also the coefficient of x in the second equation. And B1 is the coefficient of y, C1 is the constant term, here B2 is the coefficient of y, and C2 is the constant term. Now we take the ratios of these equations, pair of equations. Now, first condition is when a1 by a2 is not equal to b1 by b2. When the ratios a1 by a2 is not equal to b1 by b2, then we get intersecting lines. We get intersecting lines. Intersecting lines, and these intersecting lines have only one solution. Only one solution. We call it as consistent pair of equations. Consistent pair of equations. consistent pair of equation. When the two ratios are not equal, that is a1 by a2 not equal to b1 by b2, which is intersecting lines, and only one solution will get. We call it as consistent pair of equations. Okay. Then in second one, when a1 by a2 equals to b1 by b2 equals to c1 by c2. When all the three ratios are equal, then we get coincident lines. Coincident lines. It means you will get many solutions. You will get many solutions. Many. When all the three ratios are equal, then we get coincident lines. For coincident lines, there are many solutions, and it is called as dependent pair of equations. Pair of equations. Then third one is a1 by a2 equals to b1 by b2 not equals to c1 by c2. When the first two ratios are equal, a1 by a2 is equal to b1 by b2, but not equal to c1 by c2, then we get parallel lines. Parallel lines. We get any solution? No. No solution. And the equation is called as inconsistent pair of equations. Inconsistent pair of equations. So, these three conditions or possibilities are very important. Without drawing graph also, we can tell whether we get one solution, many solution, or no solution by finding the ratio of their coefficients. By comparing the ratios, it means that a1 by a2, b1 by b2, c1 by c2. Taking all these ratios and comparing them, we can say that whether we get one solution, no solution, or many solutions. Let us take some examples. Let us take some examples. The first example is (9x plus 3y plus 12 equals to 0), 18x plus 6y plus 24 equals to 0. Here, two equations given, pair of linear equations in two variables x and y. Now, here a1. What is a1 here? Coefficient of x. Then what is b1? Coefficient of y. And c1 is the constant term in this first equation. Take second equation. a2 equals to 18. Coefficient of x. Then b2 is the coefficient of y. And c2 equals to 24. Now take the ratios. a1 by a2, that is 9 by 18. What is 9 by 18? 1 by 2. Then b1 by b2, 3 by 6. What is 3 by 6? 1 by 2, which is also 1 by 2. Then c1 by c2, that is 12 by 24. 12 by 24 is 1 by 2. Now compare all the ratios. A1 by A2 is 1 by 2. B1 by B2 also 1 by 2. C1 by C2 also 1 by 2. Since all the ratios are equal, A1 by A2 is equal to B1 by B2 equals to C1 by C2. So, pair of equations represent coincident lines. These pair of equations represent coincident lines. It has many solutions. We call it as dependent pair of equations. So, therefore, pair of equations represent coincident lines and having many solutions. Now, second example. So, I'll take one more example. 2x minus 3y equals to 8 and next equation is 4x minus 6y equals to 9. Now, first we write in the general form. So, what is the general form of this? General form is a1x plus b1y plus c1 equals to 0, a2x plus b2y plus c2 equals to 0, right? So that 2x minus 3y minus 8 equals to 0, 4x minus 6y minus 9 equals to 0. Now take the ratios. Here a1 is 2, a2 is 4, b1 is minus 3, b2 is minus 6, c1 is minus 8, c2 is minus 9. Okay. Now take the ratios. A1 by A2, that is 2 by 4. 2 by 4 is 1 by 2. B1 by B2 equals to minus 3 upon minus 6. Minus divided by minus plus. So, 3 by 6 is 1 by 2. Then, C1 by C2 which is minus 8 by 9, minus 9. So, 8 by 9. Now, compare these ratios. The first two ratios are equal. So, therefore, A1 by A2 is equal to B1 by B2 but not equal to C1 by C2. So, first two ratios are equal but the third ratio is not equal. It means that these pair of equations have no solution. These pair of equations have no solution. So, we call it as inconsistent pair of equations. Inconsistent pair of equations. Now, we'll take one more example. Third one. 3x plus 2y equals to 5. Then 2x minus 3y equals to 7. So this can be written as 3x plus 2y minus 5 equals to 0 and 2x minus 3y minus 7 equals to 0. Here A1 is 3 and A2 is 2, B1 is 2 and B2 is minus 3, C1 is minus 5 and C2 is minus 7. Now take the ratios. A1 by A2, that is 3 by 2. Then B1 by B2, which is 2 by minus 3, which is minus 2 by 3. Now A1 by A2 is not equal to B1 by B2. Are they equal? These two ratios are equal? No, this is 3 by 2, this is minus 2 by 3. They are not equal. So that A1 by A2 is not equal to B1 by B2. We say that the lines are intersecting. So we get intersecting lines, we call it as consistent pair of equations. We get intersecting lines and these pair of equations are called as consistent pair of equation. So these three possibilities are possible. Now, on comparing the ratios, we can tell without drawing graph, we can tell whether we get one solution, no solution or many solution just by finding the ratios A1 by A2, B1 by B2 and C1 by C2. Thank you, students.